Hi guys, today we're going to talk about word problems. I have a couple of examples for you. First example is, it says, a baseball is tossed straight up into the air and after t seconds reaches a height of h feet. The following equation describes the vertical motion. H of t equals negative 16t squared plus 64t plus 6. So what we're going to do is graph this quadratic on the set of axes below and take a look at the different parts of the graph. All right, so first off, I am going to just plug this into my calculator. So my equation is y equals negative 16 t squared All right, so I'm going to input my equation, and then I am going to look at my table of, or I'm going to look at my graph, which it's going off. Let's take a look at the table here. All right, if I start at 0, I am going to look at my outputs, my y. It goes 6, 54, 70, 54, 6. So it looks like this ball is being tossed up. It gets up to 70 and it comes back down. Okay, so my maximum height is 70 feet. All right, so I'm just going to jot down a couple of these points or when I go to graph. All right, 0, 1, 2, 3, 4. Okay, so these are the only points I'm going to plot, and there's a reason that I'm only going to plot these points. One, I'm only going to look at the t values, the time values that are positive from 0 and higher, because it's talking about time. We're not going to go into negative seconds. Okay, then when I look at my output values, I'm not going to go past 4 seconds because once I get to 5, the output value is negative 74 feet. And same kind of thinking, you're not going to go into the negatives, okay? All right, so I'm going to plot this. 0, 6, 154, 270, 354, and 4, 6. Okay, now I'm just going to write a nice, connect the points with a nice, oh, that's not a nice, with a nice curve. It's going to go up, and then it's going to come back down. Okay, so that's our parabola right there. Okay, and this makes sense. Remember when we looked at quadratics, this value right here is where it intersects the y-axis. In this case, it's almost like that's like how tall the person is. You know, the ball is being tossed and it's starting at that point, at that height. Okay, so the person must be 6 feet tall. They're throwing the ball, goes up in the air, goes up 70 feet, and then it comes back down. Okay, let's look at a couple of questions that relate to the graph. It says, what is the initial height of the baseball? Oh, I just answered that. The initial height is 6. So like I said, this could mean like a person is 6 feet tall that is throwing it. How long will it take the baseball to reach the maximum height? So right here, at 2 seconds is when the ball reaches the maximum height and then it starts to fall back down. So it takes from 0 to 2 seconds. So 2 seconds for the ball to reach the maximum height. What is the maximum height? So at 2 seconds, the ball reaches 70 feet in the air and then it comes back down. So 70 would be your maximum height. How long will it take the ball to land on the ground? Okay, now this is where I'm going to go back into my calculator, because when I look at my graph, if it lands on the ground, that means that it's going to be 0 feet in the air, and that's right here. Okay, when it hits the ground, it's right here. Well, I'm not really sure exactly what that number is, okay? I know it's a little bit past 4 seconds, but I don't know exactly how much past 4 seconds. So I'm going to take a look at my graph. Now, again, I don't see my whole curve here. And this is, I mentioned last week that it's going to be really important when you're looking at your word problems to see the whole entire graph. All right, I don't see the whole curve, so I have to adjust my window. I know that that maximum value, the top of my graph, it goes up to 70. So I want to make sure that when I adjust my window, that Y max, let's make it go up to, I don't know, let's go up to 80. That way I can see the top of the curve, okay? Also, I don't really need to go to negative 10, okay, in my X minimum values, because I'm not even looking at any of the negative X values. All right, so let's take a peek at the graph now. There we go. All right, so now back to the question that we were looking at. It says, how long will it take the ball to land on the ground? Round your answer to the nearest tenth of a second. So again, this right here, this point is where the ball lands on the ground. That is also, remember, one of your roots. It's where x equals, or it's where y equals 0. It's a root. So I'm going to use my calculator by hitting second trace. I'm going to go down to number 2, which is one of my zeros. And now I'm going to scroll all the way over. Oops, I went too far. I didn't even see it go by. There we go. Here, it's back. All right, I'm going to left bound, right bound, and right there. It says 4.091. I'm going to round this to the nearest, what did it say? Nearest tenth of a second. So at about 4.1 seconds, the ball hits the ground. Okay? What is the domain of the graph? Remember, the domain is all of the x values that are being covered. When you are listing the domain of the graph, you have to think about what makes sense. Okay, what x values would we look at or have some value to them? Does their information have value to them that would make sense with the situation? Okay, so since we're talking about time and we're talking about feet, you're not going to go into the negatives for either one of those. All right, so first of all, I know that I'm not going to go into negative seconds. I can include 0 because that's my starting time. That's when you initially throw the ball. And then I am going to keep going. I'm going to look at my graph and I'm going to keep reading. When I look at my x values through the whole entire curve, all of those x values are relevant. But as soon as I get to this point, then my feet go into the negatives. So it doesn't matter. It doesn't make sense with this equation. So I would stop there. So since I just found that right here, this is my x value that I would stop at, because after that point, I would end up going into negative feet and it wouldn't make sense. Okay, so I'm going to go from 0 to 4.1 seconds. And actually, it doesn't say to round this. So I am actually going to write the whole number out when I'm talking about my domain. Okay. All right, what is the range of the graph? So again, you want to think, what makes sense? What are the output values or the y values that are relevant with this question? And since it's feet, we're looking at positive values. Okay, so the feet, the ball can be 0 feet because that's where it hits the ground after it was tossed. Okay, and then it can go as high as our maximum value of 70 feet. So the y values, or our range of feet that the ball could be, go from 0 feet up to 70 feet. Okay. Over what interval is the ball increasing? Okay, increasing, remember, means is the output going up. So from here to here, our ball is increasing in height. Okay? So we can say from 0 to 2 seconds, the ball is increasing in height. Where is it decreasing? It's going to be decreasing. It's going to turn at 2 seconds, all the way down until it hits the ground at this 4.0916501 seconds. Okay? Find the average rate of change from 1 second to 2 seconds. Include units in your answer. Average rate of change. Think change of y over change of x. All right, so what is happening from 1 second to 2 seconds? All right, from 1 second to 2 seconds, the ball goes from 54 feet up to 70 feet. So I'm going to subtract my feet, 70 minus 54. Okay, now since this was the height after 2 seconds, the bottom is your change of time. So I have to start with my 2 seconds and subtract 1 second from it. And I end up with 16 over 1. So between 1 and 2 seconds, the ball is going up. It increases 16 feet per second. Okay? Then says find the average rate of change from 2 to 4 seconds. Include units in your answer. So again, if average rate of change, I'm going to think change of y over change of x. Okay? So it goes from 70 feet down to 6 feet. So I'm going to subtract the 6 feet was the height at 4 seconds. So 70 was the height at 2 seconds. So I just have to make sure I keep the subtraction consistent in the top and the bottom. All right, and I end up with negative 64 over 2, which equals negative 32. So between 2 and 4 seconds, this ball decreases 32 feet per second. Okay, so compare our answers in J and K. So J has a positive rate because it's going up. J has a positive rate.
Should I look how Jewish stuff?
Because
Mommy,
the ball is being thrown up.
Stuff. Mommy, should I look how Jewish stuff? Look how clown.
Okay, so comparing. All right, comparing J and K. J has a positive rate because the ball is thrown up. And K has a negative rate because the ball is coming down. Okay? All right, any questions on that one? You can just shoot me an email. All right, next word problem. So this one is going to be very similar to the last one, okay? I am going to just type in, it says, suppose an acorn drops from a tree 70 feet above the ground. The function h equals negative 16t squared plus 70 gives the height of h of an acorn in feet after t seconds. What is the graph of this quadratic function? About how many times does the acorn hit the ground? Oh, at about what time? All right, so just like the last one, I am going to type my equation into the calculator. And I'm going to look at my table of values. All right, and again, when I look at this, I'm going to start at 0. So that's going to be, 70, 70. 1 second is 54, and 2 seconds is 6, and then 3 goes into the negative. So I'm just going to plot these points. Let's see if we go 10, 20, 30, 40, 50, 60, 70. Okay, so this is height. This is time. So let's do 1, 2, 3. 1 second. All right, so I'm going to plot a point at 0, 70, 154, 2, 6, and then 3, it goes into the negatives. All right, so this is going to come down like that. All right, so again, I'm thinking about when I do this graph, what makes sense. And it only makes sense to look at our positive values, okay? It says that about what time does the acorn hit the ground? So that's going to be, okay, so that is going to be our 0. The zeros is where that acorn hits the ground. So I'm going to go into my calculator, and again, I am going to find that point, the 0. There it is. All right, and it is saying at about what time. So I'm going to round this at about, we could say 2.1 seconds. Okay, and again, this graph makes sense with our situation. If you think about it, it's saying that the acorn is 70 feet up in the air, so that's where we start. And the acorn is going to fall to the ground, so the curve is going to come down. And as it falls, it goes slow, slow, slow. And then as it keeps going, it picks up speed, and that's where our curve starts to, the acorn starts to drop down quickly. Okay? All right. Next example. All right, it says Abigail is throwing a coin off a bridge into a stream below. The distance in feet the coin above the water is modeled by the equation h of t equals negative 16t squared plus 96t plus 112, where t represents time in seconds. All right, so part A, it says determine the vertex y equals h of t algebraically and interpret the meaning of this vertex in the context of the problem. All right, so this is where it goes back to being able to find those parts without just plugging things into your calculator. So find the vertex algebraically. So remember, first thing we have to do to find our vertex is you have to find the axis of symmetry, or find the x value. So t equals negative b over 2a. So I'm going to plug in 96, so I get negative 96 times 2 times negative 16. All right, that ends up equaling 16. So my t value, my time value is 3. Okay, remember that actually is your axis of symmetry. Now to find the vertex, we have to find the y value, or in this case, the y value in this case, or the h of t. So my equation is negative 16t squared plus 96t plus 112. All right, so I want to evaluate when it's 3 seconds, what is the height? So I'm going to plug in 3 for t into my equation. All right, I can put that in my calculator, and I will find out that when the t value is 3, the height is 256. So my vertex is 3, 256. Okay? Then it's saying to interpret the meaning of the vertex in context of the problem. All right, so what this means is after 3 seconds, the coin has reached its maximum height, I should say, not value, height of 256 feet. Okay. All right, how much time will it take the coin to hit the water? Solve algebraically and check graphically. All right, so if it's going to hit the water, that means it's going to hit 0 feet. All right, it's going to be 0 feet in the air. So you're going to think, what are the zeros? Now this says to solve algebraically. So we have h of t equals negative 16t squared plus 96t plus 112. Okay, so I am going to solve this equation for when h of t equals 0. So I'm going to put 0 in. Now when I look at this, I think, okay, I can factor this. All right, I can pull out 16. I can pull out negative 16. So I'm left with t squared minus 6t minus 7. Okay, I'm going to divide both sides by negative 16. So I end up with 0 equals t squared minus 6t minus 7. And now I can factor this. Okay, I can split this up into t minus 7. Whoops. T, not 7, t minus 7 times t plus 1. All right, so if t minus 7 equaled 0, that means t would be 7. If t plus 1 equaled 0, that means t would be negative 1. Now remember, t is time. I can't have negative time when this coin hits the ground. So I'm going to reject the negative possibility. So this is going to be my answer. The coin will hit the water after 7 seconds. Okay, it says to check with your calculator. So I am going to plug this equation into my calculator. Negative 16t squared plus 96t plus 112. And then I'm going to change my window because I know this is going to go all the way up to 256 feet. So I want to make sure that that y max goes up to 256. So now I can see that whole entire curve. Okay, now this makes sense. So it looks like, here's our graph. It goes up and then it comes down. So right here must be where the bridge is. So the girl is standing here, 112 feet up in the air. She throws the coin up in the air. It reaches 256 feet and then it falls down all the way to the ground. Okay, all the way into the water. All right. Okay, so that's the last example that I'm going to give you guys. I am going to copy a printout of this, and there will be an additional, I think I had put an additional example on there for you guys that you can just look at. Yes, this skeet shooting problem. You can just look over that. This is actually a systems problem. So you end up graphing a quadratic from your word problem, and you graph a linear equation from the word problem, and you just end up seeing where they cross. All right. But again, I will just copy this for you and attach it to this video assignment. Okay. If you have any questions, feel free to email me. Have a good day, guys.